today we're going to be testing the coefficient of rolling friction of a metal ball on 5 different sandpaper grids from 60, which is the roughest, to 100, 150, 220, and 320.
To better understand the relationship between the two variables, we have created a flowchart so you can see how they are connected. We use the relationship between Newton's second law and kinematics to create this. In addition, we are showing you the roughness of a 60 grit sandpaper shown here versus the 400 grit sandpaper. As you can see, the 60 grit is very rough and thick, while the 400 grit is very thin and has very little abrasive particles shown. As shown in our original diagram, you can see rolling friction opposes the direction of motion. Using Pythagorean's theorem, we calculated the angle of the incline. For the setup, we attached sandpaper to the incline using tape.
For the first trial, we are going to be measuring 60 grit by rolling a metal ball 3 times, timing each time.
Note that the ball has 2 components of acceleration, linear and angular. Using kinematics and Newton's second law, we calculated the equation for mu, the coefficient of rolling friction. Our final equation for mu uses displacement, time, gravity, and the angle of the incline. After data analysis, we compiled this graph of sandpaper grit versus the coefficient of rolling friction. The line of best fit shows a negative linear correlation between sandpaper grit and the coefficient. This makes sense because as sandpaper grit increases, roughness decreases, and therefore there is less friction. Our final conclusion is that the higher the sandpaper grit, the lower the force of rolling friction and therefore a lower coefficient of rolling friction.
Thanks for watching!